All right, now we're going to go back and do the second part, which is perpendicular. So the two lines that you're seeing here on the screen, which we labeled as lines 3 and 4, are perpendicular. So the slope of the first one we said was up 1 over 1, 2, 3, 4. So the slope of this line is up 1 over 4. Then our slope of our second line we said was down 1, 2, 3, 4, and over 1. Down 4 and over 1. And then what do you notice about the two slopes that you're seeing here? Well, we said that it is flipped, and one's negative and one's positive. So we said opposite sign. Now those aren't the fancy words, so it doesn't actually make sense. Slope of perpendicular lines are opposite sign and flipped. So the fancy words for that would be negative or opposite, reciprocal. Okay, so when we are asked to simply identify the slope, which is our first two questions here, so we're going to read the directions, and we're being asked to identify the slope. That means look at the slope that was given and then tell me what slope would be parallel to that slope and what slope would be perpendicular to that slope. So we said above that the parallel slopes are the same. So we already went through and did this part where we said the slope of a line parallel to our equation is 3 over 1. So then if you take that slope, you make it negative, and you flip it, that gets you the perpendicular slope. So if I make that negative, it's going to be negative, flip this fraction, 1 over 3. And that's our answer. For the second one, we said that this is our slope, negative 3 over 4. So parallel, which we already did, is negative 3 over 4. It's that same number. For perpendicular, we're going to do the opposite sign. So we're going to do positive this time. And we're going to flip this fraction, 4 over 3. And that is identifying a perpendicular slope to this one. Okay. Then when we went down and did level 2, we already solved this for y. So we took this x value, brought it over to the other side, and then we divided everything by 8. We already did that. So the second thing we need to do is now identify a slope perpendicular to this one, which we already said the parallel slope was negative 3 over 8. So perpendicular to that would be positive 8 over 3. Okay, same thing for this one. We should already have on our paper the process that we used for solving this for y. We already did that in the last video. Divide that by negative 9. And here's why it's super important that when we pull this slope, negative 5 divided by negative 9 should be positive. So when we pull the slope of this line, the slope is actually going to be pulled as positive over positive. Okay, and why is that important? Because if you see these two negatives and you're trying to do the opposite sign, do you do the opposite sign of both of them, of one of them, of none of them? How do I know which one to do? And if there's no negatives, it just makes life a lot simpler. So by parallel slope, we already said was 5 over 9. Now we need to make that perpendicular. So perpendicular to that is negative 9 over 5. Okay, so in order to find a perpendicular slope, we're going to change the sign. Whether it's positive, we change it to negative. If it's negative, we change it to positive. And then we're going to flip that fraction upside down. Okay. All right, I'm going to go ahead and turn the page here. We already wrote the equation, so you should already have this, and we kind of cross this out to give ourselves more space. So parallel equation, so I'm going to write the equation, which means I need to have y minus my y value, which we got from over here, equals, I'm going to steal the slope because I want to do parallel. So it's going to have the same slope as this other line, x minus, and then my x value was a -5. So minus -5 means I'm going to change that to a plus. And there's my parallel equation, which we already did. Now, to do perpendicular, I still want to go through this point. So because I'm still going through this point, the first part of the equation and the last part of the equation will be the same. Don't have to really think about that part. That part's not going to change. And all I'm doing is visually changing my slope. So when I change that slope, I'm going to go from positive to negative, and then flip that fraction upside down. Okay, and that's my perpendicular equation. So that's the equation of a line that's perpendicular to this given line and also goes through this point. What happens to this +9? Well, that's the y-intercept of my original line. I don't care about that number, that y-intercept, because my equation will have a different y-intercept. So that 9 number is actually never going to show up in your answer. Okay, it's not something that we care about when we're writing the equation of our line. Okay, let's try that one more time. So write the equation, first parallel, then perpendicular to this line. So this is what I care about. This slope is -3/1. I don't care about this. And I want it to go through this point, 7, 5. So if I do parallel, here's the symbol for parallel, so you don't have to write out the word. My parallel would be y minus, my y value is 5, equals my slope, same slope, use the same number, x minus my x value, which is 7. Then for perpendicular, this part of the equation and the last part of the equation are going to be the same because it still goes through the same point, but my slope is going to change. Instead of being -3, it's going to be positive 1/3. Okay, so when you do perpendicular, you're changing between a positive and a negative, and you flip the fraction.